guys, today we're going to be discussing speed, velocity and acceleration. I'm going to be covering what each of these terms mean and what are the differences between them. So let's jump right into it. First we look at speed. Now speed is a scalar quantity. Scalar meaning it only has magnitude. It has no direction. I will go through the example later and I'll explain what that means. So distance is the total length traveled. If you look at this car, the blue line indicates its path. So let's say this car has gone through the curve and reached on the other side. Now this light blue line indicates the distance that this car has traveled. Speed is simply the rate of change of distance. What does this mean? For example, let's say the car is stationary at this point and time equals to 0 seconds. Now after 1 second, the car has moved 30 meters. And then after 2 seconds, the car moves a further 30 meters. So it has moved a total of 60 meters in 2 seconds. So the rate of change of distance, the distance of the car from the original position keeps changing. So 30 meters per second means every second the car travels 30 meters. So that's what speed is. Speed is how fast the distance is changing. So how fast you're moving forward. If it's 10 meters per second, every second you're moving 10 meters. So this is what speed is. And notice there's no direction mentioned. So the direction here is irrelevant. As long as you're moving 10 meters in any direction for every second, then your speed is 10 meters per second. Now let's look at the relationship. Let's tie it all together. So you have to understand the relationship between speed, distance and time. These are the three important quantities that we deal with. So when it's speed, it is distance over time. So time here, whenever we have something over time, we call it a rate because we are measuring something relative to the change in time. So per unit time is normally in per second. Now units are very important here as well. So if the unit for the distance that we use is in meters and the unit for the time that we use is in seconds, the unit for the speed will be meter per second. Alternatively, this can be written as ms to the power of -1 meter per second. But if the distance was in kilometers, for example, and the time was in hours, then the speed would be kilometers per hour. It's very important that we make sure that the units match. Otherwise, we cannot perform calculations accurately. If we don't match the units, we will get the wrong answer. So when we rearrange this equation, we can also get the equation for distance. The distance is equals to speed times time, and we can also rearrange for time. So time will be equals to distance divided by speed. Now this is a very popular triangle. This is to help you remember the formulas. So you don't have to memorize all three formulas. All you have to do is remember this triangle. Now if you already know how to use it, great, but I'm going to go through how to use it. So if, for example, we want to find speed, all you have to do is use your hands, use your fingers and cover speed. So speed here, the symbol for speed is V. Okay, don't get confused with S. So symbol for speed is V. So we cover V, cover the V, then you get S divided by T. Now S is the symbol for distance and T is the symbol for time. So if you wanted to find velocity, we cover velocity, you get distance over time. So for example, if you wanted to find distance, so now we cover distance, we cover the S. When you cover S, what you get is velocity times time. Velocity times speed times time, sorry. So speed again is represented by V, right? And then if we wanted to find time, we cover time and then we get S over V. So S represents distance and V represents speed. So this triangle is very useful for you to remember all the formulas. Now velocity. What is velocity then? Velocity and speed are used interchangeably many times, okay, but they are not the same thing. They are different. So velocity is a vector quantity. What is a vector quantity? A vector quantity is a quantity, a physical quantity that has both magnitude as well as direction. Okay, now when we are dealing with velocity, we don't use distance, we use displacement. displacement is also a vector quantity. So displacement is the distance traveled but in a specific direction. So direction is involved here. Let me compare with distance. So distance here is just the total length of this arrow. The total length of this arrow, the direction does not matter. Whereas for displacement, the direction matters. So every second the car is moving, it is changing direction. So what is shown by this arrow at the bottom here is the total displacement. So when we look at this, we can say that the car has moved a certain distance east, because finally it moves from here to here. This is the total displacement. So what is velocity then? Velocity is similar to speed, however velocity is a vector, it has direction. So velocity is the rate of change of displacement. Now I'm going to compare with speed. So for speed, it is the rate of change of distance, but velocity is the rate of change of displacement. For example, let's take a velocity of 30 meters per second. Now you will see this is similar to the example before. This is because the car is not changing direction. The car is moving straight. So when the car is moving straight, at time equals to 0 seconds, that's the starting position. After 1 second, it has moved a displacement of 30 meters forward, and then after another second, it has moved a further displacement of 30 meters forward. So this velocity of this car is 30 meters per second. Every second, its displacement is increasing by 30 meters. So when we are talking about velocity, again, it's not distance, it's displacement. We have over time again, so rate of change of displacement. How fast the displacement of the object is changing, that is the velocity. So when we rearrange again, we can rearrange displacement is velocity times time, and time is displacement over velocity. We can use the exact same triangle. Now S will represent displacement, V will represent velocity, and T will represent the time. So how do we compare speed and velocity? Now let's look at this example. Given the total distance traveled for this car is 50 meters and it takes 2 seconds. Now this car goes along this path, and this path is 50 meters long, and it takes 2 seconds for the car to travel this path. So the speed will be distance over time. Now the distance traveled by the car is 50 meters, and the time it took to travel 50 meters is 2 seconds. So this is very straightforward. We just substitute inside, and we should get 25 meters per second. So the speed of the car is 25 meters per second. Now what about its velocity? Now remember, velocity includes direction. So I just want you to focus on the picture here. If you look at the motion of the car, at every different time of its motion, it is changing direction. In the beginning, the red arrow indicates its direction, so it's going this way. But after it turns, then the arrow is facing a different direction. And then when it turns, it's facing a different direction. Here, it's facing a different direction. So the speed is the same all the way. The speed might be the same. So just now we found out that the speed of the car is 25 meters per second. That means the car is moving at a speed of 25 meters per second all the way. However, the velocity is not the same because the direction changes every time. Now, the velocity at each point will be different. However, we can calculate the total velocity. So the total displacement of this car, remember velocity is the rate of change of displacement, not distance. So the displacement of this car is 32 meters east relative to this diagram. So 32 meters east. So the displacement is 32 meters east. The time taken is still 2 seconds. So the velocity of the car is 16 meters per second east. Okay, let's just compare back with speed again. So speed was, we just take the whole distance, direction doesn't matter. So distance over time, we get 25 meters per second. That means the car is moving at 25 meters per second all the way. But for velocity, the car has moved a total displacement of 32 meters east, and so the total velocity of the car is 16 meters per second east. That is the total velocity. The velocity is changing at every second, right? So you will hear this term a lot, average speed or average velocity. Now, when can speed and velocity be interchangeable? So if we are talking about a motion where the direction does not change, for example, like this car, if it is moving in a straight line all the way, the direction does not change, then the speed is equals to the velocity. And if the question does not mention velocity, does not mention the direction of the velocity, you are to assume that it is just in the same direction. There is no need for mention of the direction. You can mention in your answer in the same direction. Okay, so here, when an object starts to move, imagine you're in the car, you start driving. When you start driving, or when you start running even, okay, imagine you are running a 100-meter race. So when you start running, you're not going to start off at top speed. It takes some time for you to reach higher speed. So you're starting from zero. So it takes a short time for you to pick up speed, and then you would have reached your top speed somewhere in the middle, and you will continue with that speed until you cross the finish line, after which you will slow down and come to a stop. So this is what, look at this example here. So let's say this car is moving from A to B. When the car begins its journey, of course, its speed is 0. Okay, so when it starts to move, it's going to increase in speed until it's reached whatever speed it's comfortable with. Of course, there's going to be variations in speed all along. Okay, let's assume there's no variation in speed. Let's say you started at 0 meters per second and the car picks up to 30 meters per second, and it maintains it all the way until it reaches the destination. Now when it's going to the destination, again the speed is going to drop, the velocity is going to drop. So you notice that the velocity is actually not the same throughout the travel time. It is going to be changing. Okay, now this is the reason why we use average speed or average velocity. We take the average of the whole journey. We take the average speed of the whole journey. So if some places were faster, some places were lower, we take the average. And how do we calculate the average? The keyword here is total. So the average velocity will be the total displacement over the total time. So this is the keyword here, total. So we take the whole displacement over the total time, the whole time, and then we will get the average velocity. So for average speed, we take total distance over total time. So whenever the question asks you for average velocity or average speed, please remember the word total. Okay, so what is acceleration then? Now, velocity and speed are the rate of change of displacement and distance respectively. So how fast is the distance changing per unit time? Every second or every hour, how far is it going? At 30 meters per second, every second it moves 30 meters. At 20 kilometers per hour, every hour it moves 20 kilometers. Okay, that is the rate of change of distance or displacement. However, acceleration is a measure of the rate of change of velocity. Now, this is important because here we only use velocity. We don't say the rate of change of speed. Acceleration is a vector. So there is direction, we use velocity. Okay, so for your questions, don't worry about, as I said, as long as the motion does not change its direction, okay, the motion is in a straight line, it doesn't change direction, then your speed and velocity terms are interchangeable. Velocity is speed in this case because there is no change in direction, right? But you need to mention the direction. So if there is no mention of direction in the question, don't worry about it. If you want an accurate answer, you can say in the same direction. So the rate of change of velocity, how fast the velocity changes. So let's look at this example. At 0 seconds, the car starts off at 2 meters per second. Okay, I want you to notice this symbol here, U. U is a common symbol for the initial velocity, meaning the velocity at the start of the motion. Right? V is the velocity at the end of the motion. So V is common for final velocity. Keep in mind, this is when there are two different velocities. When there is an initial and a final velocity, we assign u as initial velocity and v as final velocity. However, if there is only one velocity all the way, if the question does not involve two different velocities, if you have a uniform velocity, then we generally use v. Okay, please don't get confused between the two. So let's look at this. So from 2 at 0 seconds, it is 2 meters per second. It's traveling at 2 meters per second. After 4 seconds, it reaches 6 meters per second. So we want to find out how fast it went from 2 to 6 meters per second. This is what acceleration means. Okay, so what is the formula here? The formula for acceleration is the final velocity v minus the initial velocity u over time t. Now again, the unit is very important. So the unit for acceleration is meter per second squared. An alternative way of writing this will be meter second to the power of -2, meter per second squared. So final velocity, now if your velocity is in meter per second, then your time must be in second, and the unit for acceleration will be meter per second squared. If it was in kilometers per hour, for example, then your time must be in hours, and your acceleration, your unit for acceleration will be kilometers per hour square. Right? So let's look at this example. So in this case, the velocity of the car is increasing. It started at 2 meters per second, but the final velocity was 6 meters per second. So we can see that it increased its velocity. The speed increased, the velocity increased, right? So how do we calculate it? We use the formula. Final velocity v is 6 meters per second. So we put 6 meters per second minus the initial velocity of 2 meters per second, u, over the total time taken, which is 4 seconds. So from 0 to 4 seconds is 4 seconds. So the answer we will get is 1 meter per second squared. Now what does this mean? Every second, the speed of this car is increasing by 1 meter per second. So at the start, it was 2 meters per second. So after 1 second, the velocity would have increased to 3 meters per second. After another second, the velocity would have increased to 4 meters per second, and so on. So this is the rate at which the speed increases. Okay. Now acceleration can also deal with a decrease in velocity. Now let's look at this example. So initially the car was moving at an initial velocity of 80 kilometers per hour. When it reached the end, the final velocity was 20 kilometers per hour. So don't get confused with the numbers. It is not necessary for the larger number to be in front. Keep in mind which is the initial velocity and which is the final velocity. Now in this case, the final velocity v is 20 kilometers per hour and the initial velocity is 80 kilometers per hour. So it would be 20 minus 80 and the total time taken is 2 hours. Please take note of the unit as well. So if it was in kilometers per hour, the unit for time must be in hours. So when we perform this calculation, we get a negative answer, negative 30 kilometers per hour squared. So negative 30 kilometers per hour. Why is it negative? Because it is slowing down. So negative, when you get a negative acceleration, it indicates that the motion is that it is slowing down. It is not speeding up. Here, when there is an increase in velocity, we get a positive acceleration. When there is a decrease in velocity, we get a negative acceleration. This means that every hour, the velocity is reducing by 30 kilometers per hour. Every hour, it goes down 30 kilometers per hour. Okay, so if it started at 80 kilometers per hour, after 1 hour, it would have reduced by 30 kilometers per hour. That means after 1 hour, the velocity would have become 50 kilometers per hour. Right? So when we have negative acceleration, we can also write it as deceleration. So deceleration here means slowing down. But when we write it as deceleration, it will be positive. Because deceleration is already an indication that it is slowing down. So it is slowing down at a rate of 30 kilometers per hour squared.